So, today we're going to talk about a really powerful idea called self-consistency. And it's all about one simple question. How do we take a single AI answer, which, let's be honest, could be totally wrong, and turn it into something we can actually trust? I mean, picture this, right? You ask an AI a really complex question, and bam, it spits out an answer. It sounds super confident, lays out all its reasoning. But can you really be sure it's right? What if there's just one tiny mistake buried deep in its logic? The entire answer could be wrong, and you'd have no way of knowing. That's a huge problem. And that really gets to the heart of it. A single line of reasoning is just so fragile. It's like a chain. One weak link, and the whole thing just breaks. But what if instead of one chain, we had a whole bunch of them? What if we could get the AI to think about the problem in multiple different ways? Well, now we're talking. That's how you build something robust. You create a consensus, and that's where real confidence comes from. So, what's the solution here? It's basically creating a wisdom of the crowd effect, but the crowd is just one AI talking to itself. If you have a really important medical question, you don't just ask one doctor, right? You get a second opinion, maybe a third. You look for what they all agree on. We're going to do the exact same thing here, but with our AI. And this technique has a name, self-consistency. It's a really clever upgrade to chain of thought prompting. So instead of just asking the AI to show its work one time, you ask it to do it several times in different ways. And then you do the simplest thing in the world. You just take a vote. The answer that pops up the most often, well, that's your winner. And does this actually work? Oh, yeah. The results are pretty staggering. We're talking about a 5 to 17% jump in accuracy. Now, that might not sound like a crazy number, but in the world of AI performance, that is a huge deal. That's a massive leap in reliability, and it all comes from this one simple trick. Okay, so let's break down how this actually works under the hood. It's a beautifully simple three-step process: generate, extract, and vote. First up, you generate multiple paths. You do this by running the same prompt a few times, but you tweak a setting called temperature to be above 0. All that does is tell the AI, hey, get a little creative, don't give me the same boring answer every time. Step 2, extract. You go through each of those responses and just pull out the final answer, the bottom line. And finally, step 3, vote. You just count them up. Whichever answer shows up most frequently wins. Simple as that. All right, let's make this real with a quick example. A store has 15 apples. It sells 6 of them, but then a new shipment of 12 more comes in. So, how many apples does the store have now? So let's ask our AI 3 times. The first time, it might do the math directly. 15 minus 6 is 9, and 9 plus 12 is 21. Looks good. The second time, it might think differently, calculating the net change first. They sold 6 but got 12, so that's a net gain of 6. 15 plus 6 is 21. Perfect. 2 different paths, same correct answer. But on the third try, oops, it makes a tiny calculation mistake and says 9 plus 12 is 22. This is exactly the kind of subtle error we're trying to catch. And this is where the magic happens. We take our vote. We've got 2 votes for the answer 21 and only 1 for 22. It's a landslide. That one incorrect answer, that outlier, it just gets drowned out by the correct responses. The consensus is clearly 21, and now we can be much, much more confident that we have the right answer. Okay, so this sounds fantastic, but you wouldn't use it for every single thing. So let's get practical. When does it actually make sense to use this technique? The rule of thumb is pretty clear. If getting the answer right is absolutely critical, use it. This is perfect for math problems, complex logical reasoning, generating code that has to be flawless, or financial analysis. But for other things, it's overkill. For creative tasks like writing a poem, there's no single correct answer. For just looking up a quick fact, it's not worth the effort. And because it's a bit slower, it's not a great fit for real-time chatbots that need to be snappy.
And that brings us to the most crucial point. Self-consistency is powerful, but it's not a free lunch. You're making a strategic trade-off here, a very clear one between cost and reliability.
Let's talk cost. Because you're asking the AI to do the same work 5, maybe even 10 times over, you're using 5 to 10 times more tokens. More tokens means 2 things. It costs you more money on your API bill, and it takes longer to get a response. But here's what you get for that price. This is the payoff. You're buying that 5 to 17% boost in accuracy. You're essentially paying for a peace of mind. And for any application where one little mistake could be a disaster, that is a price well worth paying. And you should know this isn't some fringe academic theory. The original Chain of Thought paper dropped in early 2022. Just a couple of months later, the self-consistency paper followed up, and by the very next year, it was already a standard feature in major production frameworks. This idea went from research to a real-world battle-tested tool incredibly fast.
Okay, so let's tie this all together. Here's what you need to remember. First, we generate multiple reasoning paths. Second, we use a simple majority vote to filter out the errors. Third, this is your go-to technique for objective problems where accuracy is absolutely critical. And finally, it's all about that strategic trade-off. You're paying a 5 to 10x token cost to get a really significant 5 to 17% gain in accuracy.
So, I'll leave you with this question to think about for yourself. In what you're working on, where is a mistake so costly that getting a second, third, or even fourth opinion from your AI is actually worth the price? Where does that extra reliability really matter?